All right, so 1 and 2 say determine the dimensions of each matrix. Remember, for the dimensions, we go row by column. And rows go side to side and columns go up and down. So in the first one, what would our dimensions be? 3 by 3. Awesome. We have 3 rows and 3 columns. What about number 2? 1 by 3. We have 1 row and 3 columns. So 1 by 3. Number 3, we have to write the given system of equations as an augmented matrix and a coefficient matrix. So augmented includes the answers. Coefficients is everything without the answers. So for our augmented matrix, our first column is going to be the x's, second one the y's, third one the z's, and then the fourth one will be our answers. So what would go into our first row? So first row goes with the first equation.
3, 2, 0.
3, 2, 0, 7. Because augmented has the answers. For the second one, it'd be 5, negative 11, 9, 12. And our third row would be 4, negative 6, 7, 8. Just don't forget, each column is the x's, then the y's, then the z's. So if you're missing one of your variables, put a 0 in that spot, but also the variables might not go in order. The equation may not go x, y, z. So just pay attention. Don't rush this type of question. Coefficient matrix is everything except the answers, so without answers. So we include everything from the first one except the answers. So our first row would be 3, 2, 0. Second row, 5, negative 11, 9. And third row, 4, negative 6, 7. Any questions here? All right, let's look at number 3. It says solve for x in 1/2 x plus b is equal to a. So I always like to get x all by itself first in our equation here. That way we know what to do when we plug in the matrices. So let's solve for x. What should I do first? Subtract b. So we have 1/2 x is equal to a minus b. What would we do next? Multiply by 2. So we have x is equal to 2 times a minus b. So I'm going to find what a minus b is first, and then we'll multiply that answer by 2. So our two matrices are the same size, so we can subtract them. So let's subtract a minus b. So 6 minus 4 would be 2. 4 minus 2, 2. Negative 3 minus negative 8. Be super careful here. Negative 3 minus negative 8 turns into a plus, so that would be 5. And then 9 minus negative 1 would be 10. Awesome. So this is a minus b. Next step is we have to multiply it by 2. So 2 is our scalar. We just distribute it to everything on the inside. So that would give us 4, 4, 10, and 20. So this would be x. All right, so looking at 5. 5 says we have to add a plus b. They're the same size, so we can add them together. So we add the first number with the first number. 6 plus 2 is 8. 4 plus negative 9 be negative 5. Negative 2 plus 5, 3. Negative 8 plus negative 3 be negative 11. 7 plus 1 is 8, and 4 plus 0 is 4. It's a lot of little math going on here, so just take your time, don't rush it. Let's look at number 6. What's the dimensions of C? 3 by 2. And what's the dimensions of E? 3 by 1. Can we add them together if they're different sizes? Nope. So this would be not possible. Or you could say impossible or does not exist. Something like that. Can't add them. All right, let's do 7. We're multiplying C times A. So C is a 3 by 2. A is a 2 by 3. So 3 by 2 times a 2 by 3. Can we multiply these together? Yep, the insides are the same, so our answer is going to be a 3 by 3. I'm going to rewrite them over here just to give us more space to multiply. So in C, we have 3, negative 2, negative 5, negative 4, 1, 7, times A, which is 6, 4, negative 2, negative 8, 7, 4. So be super careful. The order that you multiply matters. So I would always suggest if it's not listed in the right order and up top, rewrite it so you have it in the order that you're multiplying. The first one we're going to move in rows. Second one we move in columns. And we said our answer is going to be a 3 by 3. I always like to write the size of our answer out just so we know what's going to go where. Oops. So starting with the first row, first column, we have the first number times the first number, so that would be 18, plus the second number times the second number, so plus 32. 18 plus 32 is 50. Next, we have the first row, second column. That's going to go in the first row, second column spot. So first number times the first number would be 12, plus second number times the second number, negative 28. 12 minus 28 is negative 16. Now let's go to the first row, third column. That's going to go in the first row, third column spot. So first times the first would be 3 times negative 2, which is negative 6, plus second times the second, negative 16. So negative 22. Now we can move on to the second row, first column. Negative 2 times 6 would be negative 12, plus 1 times negative 8 is negative 8. So that would be negative 20. Then we can move to second row, second column. Negative 2 times 4 would be negative 8, plus 7 times 1 is 7. So that would give us negative 1. And then second row, third column. Negative 2 times negative 2 would be 4, and 1 times 4 is 4. So 4 plus 4 would be 8. Now let's go to the third row, first column. Negative 5 times 6 would be negative 30, plus negative 7 times negative 8. negative 56. So this would give us negative 86. Third row, second column. Negative 5 times 4 is negative 20. Plus 7 times 7 is 49. So this would be 29. And then lastly, I'm running out of colors here. Third row, third column. Negative 5 times negative 2 would be 10. Plus 7 times 4 is 28. So this would be 38. So this would be our answer. So you guys can work out 9 on your own. Let's look at the next page. For 10 and 11, we want to determine if the given matrices are inverses of each other. Let's take a look at 11. To determine if they're matrices, we have to multiply A times B and B times A and get the inverse matrix, which is 1, 0, 0, 1. So on the quiz, you have to do it this way. You have to multiply A times B and B times A and get the inverse matrix. I need to see your work for this one. Don't just find the inverse of the first one and check that it's the same as the second. You got to multiply them together. So I'll call this one A and this one B. So let's multiply. In A, we're going to move in rows, and in B, we're going to move in columns. So starting with our first row, first column, -2 times -1 would be 2. 5 times -5 is -25. 2 minus 25 would be -23. Do I have to keep going? No, if I multiply A times B and it is not our inverse matrix, then we're done. Are these inverses of each other? Nope, not inverses. We had to get the inverse matrix, which is 1, 0, 0, 1. First step that we multiplied, we see that we didn't get it, so we are done. We already know that it's not. Now in 12 and 13, we want to find the inverse of the given matrix. So let's do 12. To find the inverse, this is what we did yesterday. We want to switch the majors. So we're going to switch the position of the first two, or the first diagonal. So -6 goes up top, +2 on the bottom. And then we want to negate the minors. So we make them negative. If they're already negative, make them positive. So we have -8 and -3. And then we need to multiply this by 1 over the determinant. The determinant is the majors minus the minors. So 2 times -6 would be -12, minus 3 times 8 is 24. -12 minus 24 would be -36. So we want to distribute this to everything on the inside. 1 over -36 times -6 would give us -6 over 36, -36. What does that simplify to? 1/6. 1 over -36 times -8 would be -8 over -36. What does this simplify to? We're dividing the top and the bottom by 4. How many times does 4 go into 36? 9, so 2 over 9. Next, we have -3 over -36. We can divide the top and the bottom by 3. So we get 1 over 12. And then 2 over -36. We can divide the top and the bottom by 2. So we get -1 over 18. Awesome. So this would be our inverse, or A, -1. Don't forget to name it as the inverse. So for 13, we want to, what do we do to the majors? Switch them. So we have -9 and -4. What do we do to the minors? We negate them, so make them negative. So -7 and -5. Then we want to multiply by 1 over our determinant. So that would be majors minus minors. So -4 times -9 would be 36. Minus 5 times 7, 35. 36 minus 35 is 1. So if we multiply this by 1 over 1, what does that give us? 1. So it's the same thing. So our inverse matrix would be -9, -7, -5, -4.